There's no guarantee on the receiving host side that it gets all of the packets or that it gets them in order. So the receiver's picture could look something like this, where it's received some packets here after a consecutive stream of ones that it has received in ACK. So its receive base can't be incremented because we got this gap, but maybe it's sent some extra acknowledgments over that way. And some of those acknowledgments maybe get back to the sending host. But again, because there's this gap, the sending host will not increase its send base until it gets the acknowledgement for the missed data. So if this packet really got lost, eventually the sender will time out and resend it, and then it can be ACKed, and then things can move forward. But this is a choice for the receiving host to acknowledge packets that are beyond the receive base that have been received, with the possibility that still these other packets will need to be resent. But this idea that you send these acknowledgments for each packet received, no matter whether they're contiguous or not, that's called selective repeat. It's selective repeat because the sending host will need to keep track and eventually decide to repeat this packet, but maybe not this packet because it knows it's already done. That's one way you could do things, and it means that every packet must be specifically ACKed. But another way to do things is called go back in. And here we don't necessarily have to keep track of the individual packets. When we have a timeout at this packet, since that packet got lost, maybe all the others got lost. Or maybe it's not really worth reusing the information that the packets already got there, just send them all back. So this sounds worse because we're going to send packets that have already been received by the receiving host and that it might even told us were already received. But if that information is not so useful, then maybe the receiving host shouldn't have sent it in the first place. And so when you use a go back in strategy for resending packets, then another thing the receiving host can do is not send ACKs until it can send one that advances the receive base. So these are called cumulative ACKs because they only are sent when it would allow the receive base to move forward. So in this case, all of these packets get resent. This one is filled in for the receiving host, and so now it can ACK these first two, and at this point, the sending host will be able to advance the window, and then they won't have to send these packets again, even if others go wrong, because the send base will have moved forward at that point. Again, the advantage of this cumulative ACK is that the receiver doesn't necessarily send as many acknowledgments back. And so in the common case, when things are working well, when all the packets meant to be sent are being received here, we cut down the number of acknowledgments that have to be sent back. And it turns out then that TCP uses this strategy for that reason.